Okay, on page 17, these are all going to be opinion questions. So there's no real information that I can give you. These are all for you to answer on your own. So for mistakes are to be expected in math class, where we are learning challenging concepts and talking about our ideas. In what ways can mistakes be valuable? Just give me one reason why you think mistakes can be valuable. And then what you feel can be learned from each mistake. And then who can actually benefit from mistakes and how do they benefit? Then for number 2, a helpful motto that you may have heard: mistakes are expected, respected, and inspected. So I'm going to expect you guys to be making mistakes. I make mistakes too. We are going to respect the fact that everybody makes mistakes, and that's okay because we can learn from them. And then inspected means we're going to take a close look at what our mistakes are so we can fix them. So what does this motto mean to you? Take a minute to write about what this means to you, and then describe a time when you've seen this motto in action. So when you've actually seen us expect to make a mistake, respect that mistake, and then inspect it, correct it, or fix it. Then on to page 18. For the school play, adult tickets cost $4, children's tickets cost $2. Natalie is working at the ticket counter and just sold $20 worth of tickets. What are all the possible ticket combinations for $20 worth of tickets? So we've got adults costing $4 and children costing $2. So if we were to start with maybe all adults, if it was just adults going, and $20 worth of tickets, we should be able to have 5 adults, because 4 times 5 equals 20. All right, let's say we kick out one of those adults and put a couple of kids in, because kids cost $2. So I'm going to replace that one adult with 2 twos for 2 kids. 4 plus 4 plus 4 plus 4 plus 2 plus 2. Okay, now let's kick out that adult. 4 plus 4 plus 4 plus 2 plus 2 plus 2 plus 2. And now let's kick out that adult. 4 plus 4 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2. And let's kick out that adult. 4 plus 2 plus 2, 2 plus 2, 2 plus 2 plus 2 plus 2. And lastly, we'll kick out that adult. 2 plus 2 plus 2 plus 2, 2 plus 2 plus 2 plus 2. And that should be all the possible combinations. Okay, on to page 3. If each piece of fruit stands for a number, it's possible to figure out the number for one of the pieces of fruit. Which fruit must equal a particular number and why? All right, we've got peach and grapes. Well, I would say let's plug in a number for the grapes, because grapes are on both sides of the equation. So let's give grapes the number 10. Well, what's the only number that I could add to 10 where it would still equal 10? That would have to be 0. So the peach has to be 0, no matter what the number for grapes is. All right, for 1 times 1 is 1. 11 times 11 is 121. 111 times 111 should be 12,321. Are you starting to see a pattern here? So we can finish that out. 1, 2, 3, 4, 3, 2, 1. 1, 2, 3, 4, 5, 4, 3, 2, 1. 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. So describe a pattern, and do you think it will continue? Well, it looks like it's going to continue. So it looks like the pattern is we are counting up and then counting down. All right, now a bag holds 1 blue block and 3 yellow blocks. Okay, so we have 1 blue block and 3 yellows. How many green blocks should be added to the bag to make the probability of randomly selecting a green block from the bag equal to 1/2? So that means that we want 1/2 of our bag to be green blocks. Well, if I have 4 blocks over here, I will need to add 4 green blocks to make half of the bag be green. So how many green blocks? 4 green blocks need to be added. Joan likes to watch the birds in her yard. One morning she notices that there are twice as many robins as blue jays. If she counted 21 blue jays and robins in all, how many blue jays did she count? Okay, so we have robins and we have blue jays. And I love a good T-chart. So let's pick some numbers here. Let's say we have, there's twice as many robins as blue jays. So that means whatever number we give to blue jays, like if we give blue jays the number 3, robins is going to be twice as many. So we'll have to multiply by 2. So 2 times 3 will be 6. Now it says we have 21 altogether. So 6 plus 3 equals 9. We're not quite there. I'm going to try 5. So if blue jays is 5, we have to double it for robins. Robins is 10. 10 plus 5 equals 15. We're getting there. How about 7? If blue jays is 7, robins is going to be 14. And then 14 plus 7 is 21. There's our 21 blue jays and robins. So we have 7 blue jays and 14 robins. All right, Vipul is buying trail mix for an upcoming hike. The trail mix costs $3.95 per pound, and he is buying 2.01 pounds. Estimate, so we're not using the actual number, estimate the total cost of his trail mix. All right, so if we were to estimate $3.95, that's really close to $4. And if we were to estimate 2.01, so that's very, very close to 2 pounds, we can multiply those together. So he would be paying approximately 8 pounds. Remember, this is an estimate. All right, a cube is a 3-dimensional solid with 6 square faces. Find the total surface area of a cube whose edges are 5 feet in length. All right, so let me attempt to draw a cube. pretty close. Okay, so each edge is 5. And we want to find the total surface area. So remember, area is length times width. So if all the edges are 5, this is 5 and this is 5. So we can find the area of this face of the cube right here by multiplying 5 times 5, and that gives us 25. And then we know that we have 6 faces to a cube: top, bottom, front, back, side, side. So there's 6 faces, so we can multiply that by 6. 6 times 5 is 30, carry the 3. 2 times 6 is 12, 13, 14, 15. So we have 150, and this is feet, square feet.